The overall goal of this procedure is to assign the alpha and epsilon carbon 13-dimethylamine NMR resonance of the N-terminal lysine residue of lysozyme. This is accomplished by first reductively methylating lysozyme at low and high pH with a substoichiometric amount of carbon-13 formaldehyde. The second step is to reductively methylate the low and high pH samples with excess natural abundance formaldehyde to complete methylation. The final step is to buffer exchange the reductively methylated samples into D2O buffer for NMR analysis. In the second method, the goal is achieved by aminopeptidase degradation of a lysozyme sample. The second step is to reductively methylate the truncated protein sample with excess carbon-13 formaldehyde, followed by buffer exchange for NMR analysis. Ultimately, NMR spectroscopy is used to show the absence of carbon-13 methyl resonance to make assignments.
The main advantage of this technique over existing methods is that it allows for the unambiguous assignment of both the alpha and epsilon dimethylamine NMR resonances of the N-terminal lysine of a protein.
Label 3 1 milliliter microcentrifuge tubes with FLS, LPH, and HPH. Dissolve 3 samples of lysozyme in previously prepared buffer solution at pHs 6, 7.5,